Solving quadratic equations. The first way we can solve a quadratic equation is to graph them, and we can look for solutions. But what does it mean to find a solution for a quadratic equation? Well, if we have an equation, just pay attention to the red ones I drew here. The first example, x squared minus 1 equals 0. If we were to solve that out, if we were to solve for x, what solutions would we get? Well, the graphing method to find out the answer would be to graph y equals x squared minus 1. And when we graph it, that's what it would look like. It's a parabola. It crosses through the x-axis twice, and it crosses at the value of 1 for x and the value of negative 1 for x. So this problem has two solutions, negative 1 and positive 1. So we write that this way. We say x equals plus or minus 1. Now look at our second example. If we were to graph x squared equals 0, we would graph y equals x squared. And when we do, we actually had this example a few sections ago. The vertex is right at the origin, and it crosses the x-axis at one point, only at 0. So there's only one solution to this problem here. It's 0. So this problem we have two solutions. This one we have one solution. And now look at our final equation. X squared plus 1 equals 0. We would graph y equals x squared plus 1. And when we do that, our parabola never actually comes down to the x-axis. It never crosses the x at all. So there's no solutions for this x. There's no real number solution. Now you might say, well, how is that or why is that? Let's quickly look and see what this means. If we were to just look at the equation and solve it, we would say x squared minus 1 equals 0. So we would add 1 to both sides. We'd get x squared equals 1. Now, the way we solve for x here, if we want to get rid of that squared, that exponent, we just take the square root, and that gives us x. But then we need to take the square root of the other side of the equation. Square root of 1 is 1. Now, when we do that, we have to say plus or minus 1, because this x could be plus 1, so positive 1 squared equals 1, or negative 1 squared equals 1 as well. So we have to say plus or minus when we're square rooting both sides. Now over here we have x squared equals 0. If we took the square root here, we'd have x equals 0. There's just one solution. On this side, this third example, x squared plus 1 equals 0. When we subtract 1 from both sides, we're left with x squared equals negative 1. Take the square root of both of these. There is no square root of negative 1. There is no number times itself that would give us negative 1. So that's why there is no solution. So with every parabola, we're either going to have two solutions, one solution, or no solutions. Okay, let's solve these without using the graphing method and find out if there are any solutions for our variables. Also, just a quick note, that when you find those x-intercepts where they cross the x, those are called our roots of our equation, or the zeros of the function. There's two names that mean the same thing. Where they cross the x-axis, the parabola crosses, those are the roots of the equation, or the zeros of the function. Okay, first example. M squared minus 36 equals 0. We're going to add 36 to both sides. This is very simple equation work. And we have m squared equals 36. We take the square root. We get m equals, remember, plus or minus 6. Square root of 6 is, or square root of 36 is 6. So we have plus or minus 6. So there's two solutions. Second example. We're going to solve 3x squared plus 15. We're going to subtract 15 from both sides. When we do, we get 3x squared equals negative 15. Divide by 3. We get x squared equals negative 5. And as we've already learned on our previous examples, there is no solution for a negative square root. So there is no solution here. Our final example, 4d squared plus 16 equals 16. We're going to subtract 16 from both sides. When we do, that cancels the 16, and then we get 0. So we have 4d squared divided by 4. Still have 0, so we have d squared equals 0. Take the square root. It's d equals 0 still, so there's one solution here. So once again, this is an example of how we can get two solutions, no solutions, or one solution.
Hello?